Merhaba arkadaşlar. Swoole kitabını okumaya devam ediyoruz. Bu umuyorum ki bizim son bölümümüz olacak ve bitireceğiz bu kitabı. Önümüzdeki süreçte de yeni kitaplara başlıyor olacağız. Şimdi son bölüm, bir önceki bölümle bu bölüm arasında uzun bir süre geçti. Şimdi iyi ki not almaya başlamışız. Bu notlar üzerinden hafızamızı, bilgilerimizi tazeleyebiliriz. İsterseniz bir onlara bakalım neler yazmışız bu zamana kadar. Şimdi Mastering Swoole PHP kitabına başladığımızda ilk göreceğim şey Memory Management'tı. Orada da iki konu vardı. Stack Memory ve Heap Memory. Stack neydi? Burada işte fonksiyonlara gönderilen değişkenler veya local variable olarak kaydettiğimiz değişkenler, işte Swoole içindeki çalışan rutinler, bunların hepsi stack'te tutuluyordu. Stack'in şöyle bir özelliği vardı. Memory management'ı burada CPU tarafından yapılıyor. Stack space'te tutulan tüm değerler. İşte bir program çalıştığında stack'te onu oradaki değerlere ulaşmak çok hızlıydı. Ama stack'teki dezavantajımız buranın çok ufak bir alan olması memory'de. Yani hem de işletim sistemi tarafından limitlendiği için uygulamamız doğrudan buraya müdahale edemiyor. Buradaki çalışan değişkenlere, değerlere ulaşmak çok hızlı ve stack ne zaman e, rahatlıyor ve nasıl diyelim içinde alan açılıyor. O da fonksiyonun skopu exit olduğunda yani bittiğinde artık çalışacak kod kalmadığında. Bir de heap memory vardı. Heap memory ise doğrudan bizim uygulamamız tarafından yönetilen yer. Buraya ulaşmak daha yavaş. Yani buraya bir değer atadığımızda buradaki değere ulaşmak daha yavaş heap'e göre, pardon stack'e göre. Buradaki işte atanan değerler doğrudan e, bizim dinamik olarak serverımızda tutuyor ve yani değer limitleri, tutulabilen değerlerin alanı dinamik olarak arttırılabiliyor. Örnek veriyorum bir array tanımladığımızda mesela burada biz 5 tane item'lık bir array tanımladığımızda daha sonra bunu arttırmak istediğimizde doğrudan buraya set ediliyor ve bunlar dinamik bir şekilde arttırılıyor. Site'ye göre buraya ulaşmak daha yavaş. Bu da aklımızda olsun çünkü bu stack memory ve heap memory farkını bilmek Swoole tarafında önemli. Doğrudan Swoole'da uygulamalar memory'de tutulduğu için hangi değişkenin ne şekilde nerede tutulduğunu bilmek daha sonra bizim memory leak yaşamamamız için önemli. Linux prosesleri gördük. Linux prosesler yine aynı şekilde Swoole konusunda çok önemli. Çünkü şimdi PHP FPM ile Swoole'un farkını gördüğümüz yerde bu Linux prosesleri devreye giriyor. Bir Linux prosesi neydi? Uygulamanın doğrudan içinde koştuğu bir proses. Mesela bir CPU core'u birden fazlaysa birden fazla proses yürütebiliyorduk o işletim sisteminde. Paralel bir şekilde. Sub prosesler oluşturabiliyormuşuz. Ve buradaki sub prosesler doğrudan e, parent prosesin kopyası gibi bir şey. Bu proseslerin altında threadleri görmüştük. Hatırlarsınız. Threadler de proseslerin daha light versiyonları. Ne demişiz? Bir prosesin içine birden fazla thread oluşturabiliyoruz. Linux'te bir thread neredeyse prosesle aynı, sadece daha light versiyonu. Asıl fark ise prosesler aynı memory space'i kullanmıyorlar. Yani birbirine mesela bir prosesin atadığı değişkene diğer prosesten ulaşamıyorduk. Thread'de ise bir thread'in atadığı değişkene diğer thread'lerden atayabiliyoruz. Bu ne demek? Aynı memory space'i kullanabiliyorlar demek. Tabii bu da farklı sorunlara yol açıyor. Proses forklamak değilmiş. Yani iki tane proses forklamakla iki tane thread açmak aynı şey değil. Okey. Linux soketleri, işte soketler network üzerinden bir portu dinleyerek network üzerinden bizim iletişim halinde olmamızı sağlıyordu. Ne demişiz? Bir soket belli bir portu dinler belli bir IP'deki ve diğer soketlere bu adres üzerinden erişebilir. WRQ performans testing. Bu da benchmarking için kullanıyorduk. İşte tek single ne demişiz? Performans testi yani HTTP özelinde performans testi yapmak için bu tool'u kullanmışız WRQ. Tamam, bu da aklımızda bulunsun. HTTP2, burada multiplexing and demultiplexing konuları vardı. İşte multiplexing'de birden fazla veriyi, paketi aynı anda taşıyabiliyorken multiplexing ve singleplex pardon. Singleplex'te ise işte senkron bir şekilde ping pong topu oynar gibi bir o atıyor, bir o biz atıyoruz. Bu istekler tek tek handle ediliyordu. RPC ve gRPC konularına baktık. Swole'la PHP FPM'in karşılaştırmasını inceledik. Yine bu da önemliydi. Bu da bir önceki bölümdeydi hatırlıyorsam. Yanlış hatırlamıyorsam. Memory leakler ve Swoole modları, Base ve Process mod. İki tane modumuz vardı. Şimdi bugün ise Swoole client'lara devam edeceğiz. Umuyorum ki bu bizim son bölümümüz olacak. Şimdi ben kendimi alayım ekrandan ve okumaya başlayalım kitabı. Okey. Hadi başlayalım. Swoole clients. Our HTTP service is not as simple as just responding a hello world string to the requests. Okay. In most applications, when we process the task, we have communicated with external services such as DNS server, HTTP service, MySQL database, message queues, etc. To do this, we can use the MySQL PDU API provided by PHP or Socket API provided by PHP or any other client-side libraries. Tamam, çok basit bir şekilde Hello World örnek üzerinden ilerlemeyeceğiz diyor HTTP servisimizde. External servislere ulaşacakmışız. İşte MySQL olur, Redis olur, ne bileyim DNS servisi olur. Bunların hepsine ulaşıp belli kütüphaneler ve paketler sayesinde bu örnek üzerinden devam edecekmişiz. Ama biz kod örnekleri üzerinde durmuyoruz bildiğiniz gibi. Biz teori öğrenmeye çalışıyoruz burada. Kod örneklerini doğrudan internet üzerinden kendi dokümantasyonundan görebiliriz. O yüzden çok kod örneklerine durmayacağım. Ne kadar çok teori bilgimiz olursa pratikte de o kadar iyi oluruz. Kitaplardan da teori bilgi almaya çalışıyoruz. Çünkü kitaplardaki kod örnekleri anlamsız yani. By using coroutine supported API or library, multiple coroutines can be executed concurrently within one process. In the case using the libraries with the Linux plugin IO system call, the concurrency of the process is downgraded to be 1. The application is still performing to the jobs, but it is not so different from a normal PHP CLI process or PHP FPM process without Swoole enabled. Swoole coroutine supports the most popular client-side libraries such as Redis client, MySQL client, TCP UDP client, and also some commonly used PHP built-in functions such as fileGetContents, fopenstream, socket client, socopen, etc. In this section, we will see how to use these client-side libraries. Tamam, bu zaten bilinen build fonksiyonları ve paketleri nasıl kullanacağımızı gösterecekmiş. She will also provide the blocking IO version client-side API in case you are using them in simple client-side. A blocking IO TCP client. A TCP client connects to a TCP service and sends request, receives the response, then closes connection. Basit bir şekilde bir Swoole client oluşturuyor. TCP server'a bağlanıyor. Bir text gönderiyor ve receive ne alıyorsa onu basmış. Sonra da bu bağlantıyı kapatmış. Okay. We shouldn't use the code to the above within the Swoole server callback function because it's using the blocking IO system call, downgrading the whole processing into the single concurrency. A coroutine async IO TCP client. Compare with the above TCP client, the example similar to az öncekinin aynısını yapmış ama daha doğrusunu yapmış anladığım kadarıyla veya coroutine ile birlikte yapmış. Compare with the above TCP client example similar how to things work in normal PHP CLI and PHP FPM. The coroutine TCP client has to be executed within a coroutine context. Here we wrap it with corun. You can also or should use it within a server callback function because a coroutine context is created automatically within the server callback functions such as server on request. Tamam, Swoole'dan nasıl olması gerektiği gibi anlatmış. Bir önceki örnek ise normal PHP CLI ve PHP FPM runtime'da çalışması gereken kodlarmış. Okay. Within the coroutine context, the codes are almost the same as the blocking IO client, but we can execute multiple blocks of the client concurrently within one process. That is the magic power brought your by Swoole. Okay. We will focus on the coroutine version of client-side API from now on because they can be used in server callback and also when you are required waiting. Swoole coroutine HTTP client. HTTP client is the most useful client-side API because most of the services are provided as an HTTP service nowadays. Even some modern databases have HTTP interface. Sanırım bu Guzzle'ın alternatifi olarak burada öğrenmiş. In the example, we are sending a simple request to HTTP bin services and gets the HTTP response. You might be thinking, how about curl? The answer is Swoole has the native coroutine support for PHP curl library, so you can use curl in the same way as before. Swoole converts the curl library with the one with coroutine support internally. Sanırım orada bir middleware yapıyor curl'le kullanırsak. Okay. Coroutine friendly HTTP client libraries. When you have enabled Swoole who call flags, sanırım en yukarıda yapmışız şurada. The following clients are converted to coroutine support version as mentioned in the previous sections. Redis, MySQL, TCP client, UDP client, Unix stream, socket, Unix diagram, socket, stream, socket, client. Eğer bunu enable yaparsak şu client'ların hepsinde bir middleware araya sokuyormuş. Tamam. If you are using Postgres as your major data storage, you can still enjoy the Swoole performance by installing the Swoole Postgres library x Postgres and use it with PDU APIs. Swoole coroutine for CGI client. Sometimes we like to communicate directly to our legacy PHP application in our modern Swoole application. We don't have the resources to rewrite the whole application to coroutine friendly version. In this case, we can use the CGI client to send requests to the PHP FPM and get the responses in our Swoole server. Okay, summary. Aslında buradaki tüm olayın ana yeri bu summary tarafı. Yani şu okusak da yeterli olur bence. When using clients within a coroutine context, you should avoid using blocking IO libraries. Tamam, herhangi bir external servise ulaştığınızdaki client'teki coroutine kullandığımızda blocking IO library'lerinden uzak durmalıyız. Okay. Otherwise, your whole process is blocked by one single IO waiting for system call for all coroutine running coroutines. In practice, it is recommended to refactor your large application progressive instead of converting all in one time. You can split a part of your whole application to execute with Swoole and integrate into your old application with fast CGI client or HTTP client. Şimdi uygulama worker'lar içine çalıştığı için eğer herhangi bir blocking client kullanırsanız aslında anlamsız oluyor bu Swoole'un varlığı. Okay. Swoole table. You can share the global data in Swoole table across multiple worker processes. Şimdi worker'lar proses olarak çalıştığı için aynı memory space'e ulaşamıyorlar. Az önce bundan bahsetmiştik notları okurken. Eğer tamam bunlar ulaşamasın ama burada bir hack var. O da Swoole table. Swoole table bu yine memory'de tutulan Redis gibi düşünebilirsiniz. Key value bir database. In-memory database. Buraya prosesler, değişkenleri buraya yazarak aslında diğer proseslerden buradaki verilere erişebiliyoruz. Bu da ne yapıyor? Aslında memory space'ten değil de doğrudan Swoole table'ın kendi memory space'inden bize bir API sağlamış oluyor. You can share the global data in Swoole table across multiple worker process. Swoole table aslında not edebiliriz. Bu da önemli bizim için. Çünkü birçok senaryoda kullanılabiliyor. You can share the global data in Swoole table across multiple work processes. Swoole table object is created within the main process and manages it across the server life cycle. If you use PHP global variables, it is only available to current worker process. Doğru. If you modify the data in one worker process, the change can't be seen by other worker processes. To use the global variables across multiple worker processes on one machine, Swoole table is created in memory, high performance global key value storage in Swoole. Okay. Şunu alsak yeterli olur. We can use Swoole table to save the remote and location file descriptor of TCP connections. Bir Swoole table client'i var. New, tamam, bunu initialize edip bu şekilde kullanıyormuşuz. We can also use Swoole table to map the WebSocket file descriptors and users IDs when a user is logging in. Then when we have to send data to user, we can find the file descriptor by user ID. Swoole table can also be used as in memory cache layer of your application. The cache is shared across all the workers. It is recommended to initialize and reserve a reasonable large number of slots in the table for your application depending on the memory size of your machine because the size can't be changed once you have started the server. Şurası önemli. Size Swoole server ayağa kalktıktan sonra değiştirilemezmiş. The life cycle of the data saved in Swoole table is the same. Tabi değiştirilemez diyorum da bu kitap yazıldığındaki versiyonla şu anki belki versiyonlar farklı olabilir. O yüzden hani buradaki bilgilere de çok güvenmemek lazım. The life cycle of the data saved in Swoole table is the same as the master process of Swoole. The data is removed when you restart the server. Swoole table'ında bulunan veriler Swoole server restart ettiğimizde siliniyor. If you like to save a large amount of key value data or share data across multiple machines, it is recommended to use external key value database such as Redis or Memcache. Çok basic senaryolar için kullanılıyor. Eğer gerçekten karışık ve kompleks durumlarınız varsa external bir servis kullanmakta fayda var. Redis veya Memcache gibi. Çünkü uygulama restart ettiğimizde verilerin gitmesini istemeyiz. Eğer onlar external servis olarak Redis'te veya Memcache'de durursa onlara bir şey olmaz Swoole restart ettiğimizde. Okay, Swoole timer. Swoole timer neymiş? Imagining everything in the world is synced with a kind of ticks. Everything in real world is synced with time and clocks. Everything in a computer is synced with CPU cycles and CPU clocks. We can generate ticks per minute or schedule ticks based on real world time with Linux cron to sync background executions with real world. We can also do it in Swoole with timer within a Linux process. We can use timer to generate ticks and schedule tasks along with time. For example, sending heartbeat to maintain a process's TCP connection, checking new message in the queue, executing daily backup jobs, etc. Şu heartbeat to maintain a person's TCP connection şu demek. Bir TCP connection her zaman bir yaşam döngüsü var. Yani sonsuza kadar çalışmıyor. Burada ona herhangi bir mesaj atarak aslında yani ben seni daha sonra kullanacağım, sen ayakta kalmaya devam et. Veya sen çalışıyor musun, çalışmıyor musun kontrolü gibi her check yapabiliyoruz. Mesela Swoole Timer'la bunu yapabilirmişiz. Örnek veriyorum, bir MySQL'e bağlandığımızda bağlantı koptu mu kopmadı mı timer'da yapabilirmişiz. Veya başka ne yapabilirmişiz? Message queue'da yeni bir mesaj var mı yok mu kontrol et yapabilirmişiz. Veya cron gibi kullanabilirmişiz arka tarafta job'ları ilerletmek için. It is an in-process module similar to Linux cron, but with precious control and no external communication overhead. You can create and manage the lifecycle of multiple timers within a process to execute different tasks. Normally, it is created at server in the main process's worker start stage in each worker process and stage with the life of the process. Ya Swoole resmen bir dünya yaratmış. Örnek veriyorum, Chrono'ya mı ihtiyacım var? Tamam, Swoole Timer'la yapabilirsin veya Key-value storage'a mı ihtiyacım var? Veya prosesler arasındaki veri paylaşımı yapmak istiyorsun. Tamam, o zaman Swoole Table var. Yani her şeyi böyle basic anlamda içine gömmüş ama bence bu çok doğru bir yaklaşım değil. Çok fazla ihtiyaç olmayan şeyler barınmaya başlıyor o zaman uygulamayla birlikte makinenin içinde. Oysa ben sadece uygulama çalışmasını istiyorum. Başka bir şey istemiyorum burada. Diğer her şey external olmalı. Ya Swoole'un ben bu yaklaşımını beğenmedim. Her şey bir arada böyle İsveç çakısı gibi sunması. Devam edelim. Of course, you can also use the timer anywhere in the program. The only thing you need to pay attention is to maintain timer's life cycle. Swoole coroutine and channel. Swoole coroutine context. One important concept of Swoole coroutine is the coroutine context. A new coroutine should only be created within a coroutine context. The coroutine context can be created with the coroutine cron. A covariant context is automatically created for the callback functions of the Swoole servers. Arka tarafta bir şeyleri kontrol edeceğim. Bir saniye. Okey, devam edebiliriz. Swoole coroutine. A new Swoole coroutine can be created with the function. Tamam, coroutine create'de yeni bir coroutine oluşturuyoruz. Veya go kısa keyword ile yapabilirmişiz. Swoole provides the API call yield and call resume, so you can explicitly yield and resume within your application and give the execution rights to another coroutine or take the execution rights. Okay. Yine kodları geçiyorum arkadaşlar. Şu kodlar bile değişmiş olabilir bu arada günümüzde. We can see from the example, normally we want to execute coroutines within the coroutine context started with call run if the application only a one-time CLI script. Swoole coroutine structures. Different coroutines created in Swoole coroutines context has the parent-child relationship. You can get the current coroutine ID, the parent coroutine ID with the API call get CID and get PCID. Swoole channel. Swoole channel is used for the data syncing and communicating between different coroutines. It is similar to chan in Golang. Tamam, Go programlama dilindeki channel'lara benziyormuş. You can think of it as FIFO, first in first out, sanırım onun öyle hatırlıyorum açılımını. Queue system, yani ilk giren ilk çıkıyor. System with the fixed length, it can be defined as this. Tamam. Then you can use the methods chan push and chan pop to push and pop data from the queue. Unlike SPL queue is just limited by memory size and has no limitation of the queue size. When the queue is full, the operation push is blocked. When the queue is empty, the operation pop is also blocked. So it can be used as the middleman to sync data and stress between different coroutines. Let's look at the complex example. Our two coroutines sync with each other through the channel. Channel arasındaki iletişime bir örnek. In the example, the first coroutine sends an array periodically to the channel once per second. The second coroutine gets the data from the channel and prints into the screen. Internally, when new data is pushed into the queue, the coroutines waiting for data are notified and start to consume the data immediately. The above example is a basic producer and consumer or pub sub example. There are many use cases of using Swoole channel as a communication channel between multiple coroutines. You can implement the CSP model with channel and coroutine. Implementing a connection pool with channel, implement a simple pub subsystem multiplexing channels on the same connection. Timeout on the operation. You can set the timeout on both channel push and channel pop methods. If the timeout is not set, which is the case by default, the operation is blocked infinitely. This can be used when you need to timeout mechanism. Close the channel. There is a method channel close which closes one end of the channel and notifies the other end and interrupts the current waiting status. It is useful when you need the one-time synchronization during the server shutdown stage. When the server receives the kill signal and shut down the workers, we can stop the current waiting status and do the final cleanup immediately. Okay. Use cases and patterns. This is the most exciting sections. We will discuss how to apply Swoole on some real-world problems. Some of these problems are asked lots of times by the community members. Tamam. Community tarafından en çok sorulan ve karşılaşılan sorunları görecekmişiz. There is no limitation to build either a business software, system software, or middleware. By integrating with Swoole PHP, people can see 2 times, 5 times performance gain immediately. HTTP services. Build a simple HTTP 1.1 service with Swoole PHP. You can build HTTP services either for internal servers or public API with Swoole. Tamam, bu Swoole'la zaten yapacağımız şey HTTP client değil, HTTP server. Bizim için önemli olan yer burası. Yani PHP uygulamamızın doğrudan bir web server gibi çalışması lazım. Yani Nginx'e veya PHP-FBM'e ihtiyaç duymamamız lazım bizim. HTTP server doğrudan PHP'nin içinde olmalı bu şekilde. Swoole'la birlikte bu HTTP server'ı ayağa kaldırabiliyormuşuz. Okay. Ya yine bu hani kodlar belki güncel olmayabilir, o yüzden çok üzerine durmuyorum bunların. You can execute the above code with PHP CLI when you have installed Swoole PHP extension, then access the servers with IP address and port number. By putting more complex code within the request callback, you can integrate any existing PHP frameworks having the request and response model with Swoole. If you like to integrate your existing PHP framework with Swoole server, you have to create an adapter to convert the request and response objects into the format you are using. When we are executing PHP functions such as echo or print in Swoole server which are normal output data into web browsers, the output is not displaying an HTTP response but your current command console. Hosting static files with Swoole server. You can host static assert files with Swoole server by enabling the server setting enable static handler, but you should be very careful by enabling this feature. Don't expose your private files to the internet. Yani buna çok ihtiyacın olmayacak benim kişisel olarak. This feature is not recommended on production since you can host static files with Nginx and other proxies and case servers. Data processing. In a nutshell, data processing with a PHP script is similar to the data processing of a request processing is in an HTTP server or similar services. The issue of single process PHP script. Single process PHP scripts are very popular in PHP application. People use it as a cron job to do one-time or regular tasks like sending daily or weekly email, importing a CSV file into the database, etc. Yani e-mail atmayan veya bir rapor oluşturup CSV göndermeyen herhalde hiçbir uygulama yoktur. Yani çalışmamışsınız herhalde. It is handy and very simple and easy to understand because in the script are executed sequentially. But the problem is once we have tons of the data needs processing, especially when there is database read and write operations within the script, the problem becomes difficult to solve with the single process PHP scripts. Tamam, yani çok büyük veri var ama sizin sadece bir tane PHP prosesiniz var ve bu büyük veriyi, bu big data'yı handle ve operate etmek çok zor bu bir tane PHP prosesi içinde. Doğru. You may have to divide the data into several parts of multiple scripts in parallel to speed things up. Tamam, Swoole worker'larına bu veriyi bölerek aynı işi paralel olarak birden defa aynı anda yaptırabilirmişiz. Utilize all the resources to the data processing. Like the Swoole server, we can use Swoole to utilize all the power of your machine and save the time of processing the data. One simple approach is just sending all the records to your Swoole server, then the Swoole server can process the data like a web service. Use the power of multiple machines. If you like to speed up it further with the power of multiple machines, you can push the tasks into the message queue, then pull the task and execute the task with the Swoole running on multiple machines. Your system becomes a distributed system. Okay, zaten e, mantık aynı worker'lardaki gibi. Sadece makine oluyor her bir Swoole server. HTTP PHP proxy. Bu ne demek? Swoole PHP can be used to build HTTP proxy to inspect requests and responses or even to modify request response header to bodies on the fly. Nginx gibi çalıştırabiliyormuşuz. Yani sadece Nginx gibi davran diyor biliyormuşuz Swoole. Suppose you have an HTTP server running on localhost and port 3000. We can create a simple HTTP proxy server to inspect requests like this. Okay. Swoole PHP also provides the fast CGI protocol and PHP FPM proxy to talk directly with PHP FPM applications without a middle layer HTTP protocol conversion. A PHP FPM proxy looks like this. Okay. You can execute any of your PHP applications with this proxy server. You have to change, to modify, and you have the chance to modify or override the HTTP requests and responses within the server on request callback functions to build some features such as rate limiting, security check, authentication, or other expectations. Sidecar process. Swoole has a powerful feature which is allowing you to attach a Linux process on the Swoole server within the function server add process. This is useful when you want to manage an external Linux service or common tool. The lifecycle of the Linux process is managed by Swoole server. It is started when you start the Swoole server and can be terminated with the Swoole server. Swoole server can also communicate with the process, so you can expose any Linux process as a web service. Let's look at a simple example. Tamam, doğrudan işletim sistemi tarafından değil de doğrudan Swoole server tarafından yönetilen bir Linux prosese sahip olabilirmişiz. Okay. The benefit by adding a process as a sidecar process on Swoole server is you can pass variables into the process and communicate with the process with API, then integrate it seamlessly with your Swoole server. For example, as for a super large scale and busy system, you can use a different process to dispatch message to all the connected clients and avoid the case that requests are blocking the message dispatching task. Okay, TCP servers. HTTP servers we can see everywhere are a type of TCP service because HTTP protocol is built up upon TCP protocol. Tamam, HTTP servisi aslında TCP protokolün üstünde çalışıyorlar. It is recommended to do HTTP protocol if you don't have special requirements since HTTP is widely adopted. But in this section, we'd like to show how to build TCP services from scratch with Swoole. Tamam, HTTP yerine TCP servisi nasıl oluşturabiliriz bunu gösteriyor. Unlike HTTP services, TCP services may be a request response model or stream-based model. Data frames may be used to serve multiple requests concurrently with a single connection. Before building a TCP service, you have to design your application layer protocol, which is how the client and server communicate with each server. Decide the lifecycle of the TCP connection, then when to disconnect the TCP connection, whether to share one TCP connection with multiple requests, etc. A very simple TCP service look like this. En basit şekilde bir TCP servisi nasıl ayağa kaldırırız onu göstermiş. Receive'lerimiz var, close'umuz var, connect'imiz var. Bu üçü de zaten default keyword'lerimiz TCP connection'lardan. After you execute the PHP command to run this script, you can send TCP packages and get responses with tools NC or Telnet. The server responds to the request and closes the TCP connection immediately. In a real-world TCP applications, you may like to keep and share the same TCP connections by multiple requests, only disconnecting when the client is no longer using the service. Tamam, her request başına patmadı, client olmadığı sürece kapat diyor TCP servisini. Çünkü sürekli ayakta kalsın ki gelen istekleri anında karşılasın. Hardbat mechanism is also commonly used. The client sends a ping package to the server and server responses upon the client is in a fixed interval to detect where a client server is physically connecting alive. Bundan bahsetmiştik Hardbat mekanizmasından. Eğer bir TCP connection kullanmaya devam etmek istiyorsak arada bir böyle ping pong oynar gibi bir paket gönderip sen ayakta kalmaya devam et diyebiliyoruz TCP servisine. Bu bir MySQL olabilir veya başka external servisler olabilir. Bunu da mesela Swoole Timer'la daha basit yapabilirmişiz. WebSocket Server. Hello World WebSocket Server. WebSocket Server is one of the most commonly used features of Swoole. A scalable and high-performance WebSocket Hello World server can be created with the several lines of code like this. Open message close. Compared to the above code with any other WebSocket solution, it is simpler and easier to maintain. You can change the IP address and port number other than you only have to write the PHP codes to respond to the request, frame data sending from WebSocket and server to or push data to connected client with server push within the message callback function. Let's look at the more complex WebSocket server and client example, including some features in the next section. Okay, bakalım. Ya ben bunların hala geçerli olduğundan şüpheliyim bu kodların. O yüzden geçiyorum buraları da. Bakalım ne yapmaya çalışmış kodların içinde. You can save the above code into a file app.php at your current folder, then start with PHP app.php. By doing this, you have got a complete WebSocket service. You can interact with your browser
Open this address at your browser, you will see the time service is pushing to the latest time to your browser every 2 seconds. Each connection is identified with frame FD file descriptor. You would have to manage the mapping the connection to a user in your application because a user may establish multiple connections by opening multiple browser tabs. Normally, you can manage the connections IDs, FD and user IDs, user ID mapping to with Swoole table or external storage such as MySQL or Redis. When you look to the proactively push message to all the connected users, you can loop through all the connected users and call server push. The open function is very handy to write server-side functions for each connection. You can use coroutines, timers, tables within an open callback to push messages to the clients. In the meanwhile, you can serve the request sending from the clients within the on message callback. Task scheduler. Swoole timer provides 2 milliseconds trigger and timer. You can schedule your tasks more preciously with Swoole and without an external system. You can also do this within the server worker start callback function. Then the lifecycle of your scheduler is the same as the lifecycle of the server. You don't have to take any other care about starting or stopping the scheduler. Okay. Tamam, geldim. Most Swoole-based frameworks use the timer to replace the Linux cron. Most Swoole-based frameworks use the timer to replace the Linux cron to execute tasks periodically or schedule tasks to run in the future. Ben buna kesinlikle karşıyım. Swole'u kullanmazdım ben şey için. Ne için? Linux cron yerine. Okay. Producer and consumer. We will introduce how we can use Swoole for concurrent events and data processing. We may want to limit the concurrent connections to external services or like to limit the speed to leave resources to other applications on the server. Another common problem we know is to limit the rate per second or concurrent level to external services. We can use a channel to build a limiting system. These problems can be solved with ideas of producers and consumers. Use coroutine. Ya görüyor musun? Her şey için Soul kullandırtıyor bize. Yani Soul server'a bağımlı olmak kadar doğru mu bilmiyorum ya. Bana yanlış geliyor. Use coroutine. If your application is IO bound, you can just use coroutine with a Linux process to build the producer and consumers. Okay, we can use the channel as a queue, create one coroutine as a producer to loop through the requests we have and push into channel, create and coroutines and consumers to pop data from the channel. Use processes. We can also build the same system with multiple processes if the application takes too much CPU and we have to scale it across multiple processes on multiple CPU cores. And concurrency mapping. Demultiplexing and multiplexing are always used to manage scale of concurrency. Şurası multiplexing, bu multiplexing demultiplexing yapıyor, sonra bunu tekrar multiplexing'e çeviriyor. In the high concurrence system, you normally have to map m concurrent request connections into similar and upstreams service connections, such as database, in order to protect the upstream system and avoid it being overloaded with connections. When you are using PHP with high concurrent connections, each process has a new connection established to your database. Okay. Your database can easily be overloaded by the concurrent connections since each user is holding one database connection. Because in most databases, each connection is mapped to the bit thread. When there is a large number of connections, a database could be crashed just because of the large number of connections. Tamam, her user başına connection açmak yerine uygulama arası bir tane connection aç. Bu user'lar o uygulama arasındaki bir tane connection'dan iletişime geçsinler. Veya birden fazla. Ama her user başına açma diyor. The database can also be slowed down by a high number of operations. Doğru. But with Swoole, we can map the high concurrent client-side connections to a limited number of database connections. On the other hand, we can merge multiple operations into one operation to the upstream service such as batching. Multiple SQL operations as one single SQL operation by using a butter. That is why Swoole PHP is high concurrence solution. You can just create a connection pool for the upstream service. You can find more about how to use it in the next section. You can also find how to build general connection pool in the next section. The general idea is using a fixed length queue to manage the upstream service with Swoole channel or use PHP SPL queue. Multiplexing and demultiplexing. Multiplexing and demultiplexing are similar to producers and consumers, but we can do it in a different approach. Instead of using external queues or variable storage, sometimes we have to solve the problem such as how to send requests from multiple connections through a single TCP connections to the upstream service. Multiplexing protocol. In order to merge the requests from multiplexing multiple connections and send them through one connection, or a few connections, the pre-requirements are the protocol should be multiplexing protocol and support multiple streams. The commonly seen multiplexing protocols are HTTP2, TCP, etc. With HTTP2 protocol, you can send multiple HTTP requests concurrently through on one HTTP2 connection to an HTTP2 server. You can learn more about how HTTP2 works in other sections. Some protocols with request and response models can be merged or sent concurrently by default, such as MySQL requests, because if you are sending multiple requests at the same time and receive multiple responses, you are not able to match one specific request or response. You can only send one request, wait for the response of the request, then do it for the next request. In the other words, you can only manage the one concurrency with one connection. Some words about MySQL concurrency. In practice, you only can manage one concurrency with one MySQL server connection. On the server side, each MySQL connection is mapped to the Linux thread. This is the reason why we should not create too many connections to MySQL servers. So even if your server supports a large number of concurrent users, these users are sharing a limited number of upstream MySQL connections and MySQL database concurrency. With Swoole, you can create a limited number of MySQL connections and reuse them for all your requests. Don't be confused about the single concurrency at the MySQL server side versus the concurrency at the application server side. In Swoole server, when you process the request, you can send multiple MySQL requests concurrently with multiple MySQL connection instances to enjoy the faster processing. Multiplexing protocol server. Back to the original question, how to manage and concurrency mapping. The most common solution is sharing and reusing limited number of upstream service instances for all your concurrent users. The other way to handle this problem is to use a multiplexing protocol between your services or design your multiplexing protocol. To support multiplexing, you have to mark each request with an identifier, send the ID with the request, then send back to the ID with the response. Then merge the request and response at your client side of the service. Summary. The reason why concurrency management is important is that in practice most connected clients in some time point are idle or not consuming all the upstream resources. Even the resources are limited. To better utilize all the resources, we have to properly manage system design. At this point, you may be excited to implement a multiplexing protocol with Swoole server and client. Concurrency management is the most common problem of large-scale web systems, and it is necessary to resolve for any system architect. Normally, you have tools such as Linux process, threads to manage concurrency, but with Swoole you can use lightweight threads coroutines which are more scalable to manage a huge number of concurrent clients. Connection pooling. The concept of connection pooling has seldom been used by PHP applications because PHP has a stateless nature. With Swoole, you can reuse connections by managing a pool of connections. When we are talking about connection pooling, we always mean the connection established within your code as a client side to external server, service like database or cache. On one hand, by using a pool of connections, the cost of connection reestablishment is reduced. On the other hand, you can keep a maximum number of connections to the service to protect the service and avoid overloading the service. A basic pool can be created by a fixed length queue. You can push a number of connection instances into the queue. When a connection is required, popping an instance from the queue, then release the instance by pushing the instance back to the queue. You can also define the more complex strategy of how to reuse the connections by random sequence or round robin. Implement a pool of resources with SPLQ. A general reusable object pool or connection pool implemented with SPLQ can be created like this. We use Redis connection pool as the example. SPLQ. We have created a fixed number of Redis connections and pushed them into a pool. When the server requires a Redis connection instance, there is no one available. We pop one connection instance from the pool. If there is not one available, we have to wait for 10 ms, then try it again. After, when we have used the connection, we push it back into the pool, so it is available to be used by other requests. We can use the above pool of resources in the Swoole server like this. In the above example, we have mapped a large number of client-side concurrent connections into one connection to the upstream Redis service. Okay. This is a general idea that can be used on all the connection-based upstream services, even the client library is blocking I/O only. You can also do this with Swoole channel. It is handier since your code can be blocked when there is a connection object available at the pool, so you don't have to wait 10 ms. Instead, your call will continue as soon as there is a connection object available. Swoole has the built-in Swoole connection pool class based Swoole channel, makes it easier for you create to manage and a pool of instances. You can find more at this link. Building connection pool. Swoole database PDO pool is an implementation of Swoole connection pool. You can use it within your application like this. You can also use the built-in MySQL pool and Redis pool in a similar way. Define your own connection pool. You can define your connection pool and reuse the connections by extending connection pool. Okay, summary. Connection pool is generally recommended to be implemented for all Swoole server or the framework based on Swoole when you have to access data in database or cache server. You can limit the number of concurrent connections to the external storage servers and also reuse the connections for different requests. Tamam, özetle yani 1000 tane kullanıcı ve 1000 tane request geldiği zaman bizim 1000 tane connection açmamız gerekiyor. External servislere. İşte MySQL olur, Redis olur. Ne yapıyoruz? Bir tane havuz oluşturuyoruz. Örnek veriyorum 10 tane hazırda bekleyen bir tane Redis havuzumuz var. Request'ler geldikçe bu 10 tanesini kullanmaya başlıyor. Eğer available bir tane connection client'ımız yoksa 10 saniye, 20 saniye diyorum, milisaniye veya 20 milisaniye bekliyor. Hazır olana kadar sürekli tetikliyor bunu. Eğer biz 1000 tane oluşturursak bu request'leri pardon connection'ları request başına ne oluyor? Hem bizim Redis'imiz veya MySQL'imiz bozuluyor hem de network'taki bu thread'ler üzerinden bandwidth'imiz artıyor hem de işletim sistemindeki CPU kullanımı ve memory kullanımı artıyor 1000 tane oluşturursak. 10 tane oluştur. Bunları request'ler arasında dağıt diyor bu pool mekanizması ile birlikte. Swoole'da da pool oluşturabiliyormuşuz bu şekilde. Connection pool'ları veya client pool'ları. Web Spider and Scraper. Swoole is suitable to build Web Spider and Crawler. You can use only one process to crawl hundreds of thousands of different websites at the same time, thanks to the Swoole coroutines and Swoole coroutine HTTP client API. Without Swoole coroutine, we have to map one HTTP connection to the remote domain to one Linux PHP process. Before maximum server bandwidth, you are running out of the memory of the server or even CPU caused by context switching and managing so many Linux processes. With the above code, you can read the URL list from a file from the message queue, then push them into the channel. All the HTTP client instances execute the requests in parallel. Once you have downloaded the content, you can either save them into another message queue or execute a data extraction process, such as an extract database on XPath or CSPath. In practice, you should take care of the request frequency to website. You shouldn't send too many requests in a short period of time to DDoS the website, otherwise you may take the website down or be blocked by their firewalls. It is also a good practice to identify your robot with a user agent string to tell the webmasters who you are and the purpose of your spider is. Pops-up system. In a publish subscribe messaging queue system, senders are not programmed to send their message to specific receivers. Rather, published messages are sent into channels without knowledge of what subscriber there may be. Subscribers express interest in one or more channels and only receive messages that are their interest without knowledge of what publishers there are. This decoupling of publishers and subscriber can allow a greater scalability and more dynamic network topology. Yani publisher'larla subscriber'lar birbirini bilmemeli, birbirini tanımamalı, hatta varlığından bile haberi olmamalı. Publisher bir kuyruğa mesaj atmalı, e, receiver'lar da onu almalı ve dinlemeli. Yani publisher'la alakası olmaması lazım. A publish subscribe system can be created in different ways depending on the scale you require. We can use Swoole to build a very simple pub-sub system without an external system. Görüyor musunuz? Swoole her şeyi yapabiliyormuş yani. Bana hala çok saçma geliyor. Keep things simple. We only manage one topic. All the clients can publish a message to the topic. All the subscribers on the topic are notified when there is a new message published on the topic. Here we choose the most popular WebSocket protocol. You can use either TCP, HTTP2 or other protocols. We use FTS to track, FT gördüğümüz zaten file descriptor'ı anlamamız lazım. Track all the client connections on the server. Each client can send a message to the server. Then the message will be broadcast to all the clients, including the client sending the message. In real-world applications, you may like to exclude the some client sending the message or manage multiple topics. In the above example, we run the system with a single process with Swoole base mode. You can use the variable FTS safely. If you use multiple worker processes, you have to store the FTS in Swoole table to allow multiple processes executing concurrently. If you like to scale the pub subsystem across multiple machines, you have to store FTS in external storage like a MySQL database or in memory key value database Redis. The Hello World pub subsystem we have created is different and not related to Redis pub sub feature. We can also build the pub subsystem with the Redis pub sub feature. Server send events. Server send events is a way to do real-time data streaming with HTTP 1.1 protocol. Unlike HTTP2 or WebSocket, SSE is restricted to unidirectional communication. The data is only sent from server to client. It is useful for one-way communication such as stock price, data, or match scores. SSE is also supported by most browser-based clients except IE. A client is receiving real-time stream events from a server over an HTTP connection without polling. An example SSE implementation with Swoole like this. If you use an Nginx as a proxy, setup should be like this. You can use the event source API in JavaScript if your client is non-IE browser. Each message pushed from the server side is split by double newline character, and in practice, it is recommended to use an ID field within your message body to identify each message. Server may send duplicate messages, so the client side just had to ignore duplicate messages by ID. You have to maintain a list of all the connected users at the server side to push messages to different users. Then think about connecting, then the connection is dropped from the server anytime. You may also have to send hardbat messages to keep the connection established in case the proxy terminates the connection when there is no packet sent on it. Because HTTP2 is a backward compliant protocol, you can enjoy all the benefits of HTTP2, such as data efficient, automatic multiplexing, secure data transfer by using SSE or over HTTP2. SSE is simple and easy to understand compared with the other real-time protocols. Integrate with Linux process. As mentioned in the previous sections, we can expose the Linux process to build web servers. We can access the power of all Linux tools and commands such as wc, grep, top, ls, etc. within our Swoole server. Okay, doğrudan bir Linux prosesi oluşturabiliyoruz. Swoole tarafından yönetilen. Okay. You can save the above PHP code into a file called a PHP and above the HTML code into a file called WS HTML. Then execute it PHP at PHP. Open the link, this link in your browser. Please make sure HTOP is installed on the machine before using it. You will see the output of HTOP is updating on your browser in real time. You can find how to generate ticks within the onWorker start callback function. Timer can be used to generate ticks for sending and pushing data regularly to the connected devices or sending ping and pong messages to keep the persistent TCP connection is alive. Okay, summary. In this section, we have shown how to expose a native Linux command and process to be a WebSocket service. You can also export it as an HTTP service or push the data into a remote central server to analysis. Service governance, RPC and gRPC. Instead of providing all your microservices as HTTP services, you can build your system upon an RPC framework. The possibility of building an RPC or gRPC service with Swoole is one of the most popular use cases of Swoole. RPC frameworks keep your service caller and services wholly transparent with the service location. It could be on another machine or even on another data center. We take gRPC over HTTP2, for example. You can define your service and methods with protocol buffers, then generate the stub code and implement them. Define gRPC protocol. You can save the above code as hello world.proto, then PHP stub code for the both server side and client side. gRPC client with Swoole. The following code is how gRPC client side look like this. Okay, we can see calling a remote service is as simple as calling local methods, although you have to know the service address and port. You may have to choose or build a service discovery system to manage all your services if you have many of them running on different servers and locations. gRPC service with Swoole. The following code is how a gRPC server side integrated with Swoole HTTP2 server like this. Buraları kodu yavaş geçiyorum ki yani durdurmak isterseniz diye videoda. We can see except the gRPC parser which is used to extract the data from the data frame and serialize data sending back to the client. It is almost the same as an HTTP service. The benefits: we can send multiple concurrent RPC requests over one HTTP2 connections to server instead of establishing lots of connections to enjoy all the benefits of HTTP2 improvement. When you are building an RPC service based on HTTP2, you have to think about the concurrent model of Swoole server. The concurrent RPC request on streams on one persistent connection is only being sent to the same Swoole worker process. In order to use all the workers, you may have to establish multiple TCP connections to the same HTTP2 Swoole RPC server. Some gRPC clients may only use only one TCP connection by default. Summary: service governance and RPC frameworks are out of the scope of the Swoole PHP, but Swoole PHP provides the basic ability for you to build a production-ready RPC system and write your services with the PHP languages you have already known. Instead of transforming your PHP team to learn and use other languages or frameworks, you can just apply Swoole and RPC to your existing PHP system to improve the performance of the team and also the services. Okay, rate limiting. General idea. Rate limiting'ini mi ben Swoole yapacağım mesela? Ne alaka? For the production system, we have to protect the system from DDoS attacks, server overloading, or slow down brute force password guessing attacks. We may also have to protect the upstream services or external services to avoid running out of credit limitations during the period. If we want to build a web scraper to have harvest information, we also need to think about the rate limiting to avoid the case that one website is overloaded or being blocked by their firewalls. We can use Swoole table to implement a rate limiting feature for your service based on the IP address or of clients or the application layer user ID targeted URLs. The idea is counting the request number of each IP or user ID and saving it to a Swoole table, then checking to the request count of each IP during a period to decide if we allow the IP or block it. Then we can use Swoole timer to clear the outdated data in Swoole table regularly. Try and fail. We can try the above code in a loop to see how it works. You can execute the above code with PHP CLI to see if the rate limiter has limited a specific request. We have simulated access at servers once per second from the above IP address. You can see how many times the IP has access to servers during a period, which is 3 seconds here. The access count is reset every 3 seconds by the Swoole timer. Use rate limiter in an HTTP service. Then we can integrate the above rate limiter into your web service. Execute the above code. Open this link at your browser, then refresh the page. You will see your request may be blocked if you access the service more than 5 times during 3 seconds. Summary. We have just shown how to implement a very simple rate limiter for your HTTP service. The real-world rate limiter is much more complex compared with the above prototype. You may have to change the IP address with the IP you can get from HTTPX forwarder for header if your server is behind an HTTP proxy. Otherwise, you can only get the same IP for all the users. Design custom TCP protocols. Yani önde bir HTTP proxy varsa header'dan al diyor. Yoksa çünkü Swoole server'a istek atan bir öndeki HTTP proxy olacağı için sürekli HTTP proxy'nin aynı IP adresini alırdık. Yani hep tüm user'lar için aynı adresi alırdık. Design custom TCP protocols. We can design a custom TCP protocol with the handy API provided by Swoole. Think about the case when we want to broadcast real-time data from a TCP server to all the clients connected to it. We can serialize the data as a popularly used JSON string format, then prefix the string with package length and using length function provided by PHP. Package data like this, then send to the clients over TCP. This is very simple and basic prefix length TCP protocol, including the package length at the beginning, then with the real payload data. Because TCP is a stream-based protocol, we can get the package length firstly, then read up to the length of package. The code is easy to understand. When a TCP connection is established, the server is sending a data packet to the client every 1 second. The payload of the data packet is a JSON with concurrent timestamp. A different coroutine is created for each TCP connection to execute the logic. The coroutine exists when TCP connection is disconnected or lost, as the server is checking whether the connection is still connected to each loop. At the client side, we can use a prefix length parser to deserialize the data packets. We have coroutine to create a new coroutine context and include all the coroutine client's codes. The TCP client is set up to parse the TCP data package based on prefix length, so you can receive the whole data packages without parsing yourself. The TCP client strips the first 4 bytes, which is the length info, then we can get the JSON data package. Monitoring and reporting. One useful use case with the Swoole is that you can build a small Swoole PHP applications or install it as an agent on all your machines and collect monitoring or logging data. Then push the data in a central place such as a time series database or your monitoring system. You can get all the kinds of metrics about your instance server and also your application such as disk usage, memory usage, CPU usage, and metrics about a Linux process, the service running on the instance, even the request latency, QPS, TPS of your service. You can check the example in chapter integrate with Linux process. We will not provide other examples in this section. Integrate with Linux process örneğine bakabilirsiniz demiş. Hosting and deployment. Once we have built an application and like to run it on your server, we can start to look at how to host your application. In this section, we are going to discuss how to host and deploy on Kubernetes or bare metal machines. Docker and Kubernetes. If you are not familiar with Docker, it is a container technology to run dedicated OS environment inside your current OS. It helps us to create an identical environment for development and production, whatever OS your development machine uses. You can use Windows, macOS to run Linux environment the same as production. Keeping the environment consistent can help us avoid lots of issues. You won't have to worry about you can see the issues happening in the production environment at your local development environment. Kubernetes is the container orchestration system that helps you manage multiple Docker containers, glue them together, and also manage the lifecycle and scaling. With Docker and Kubernetes, you can keep your overall infrastructure at your codebase and manage data changes with Git or other version control systems. Your infrastructure is isolated and not locked on hosting providers. Bundle your own Docker file. We can start with the base Docker file PHP 7.4. You can change this depending on the PHP version you require. We have also included some useful commands for debugging and learning purposes. You can use htop to view the Swoole process structure. Bir Docker file örneği. It is worth to mention dumping is a minimum in a system to pass signals to the Swoole process. Otherwise, you hit Ctrl C, the server is not terminated and stopped. You can find more about the links in the system and signals handling. You can remove the tools such as ProCPS and htop in your production system. These tools are useful when you like to inspect the Swoole application. Foreground process. Docker requires the server's process running in foreground mode, which is the default mode of the Swoole server. We will learn how to run Swoole applications in daemon mode in the next sections. Manage the logs of Swoole application. If the Swoole server is running in foreground mode when you execute the application with PHP CLI, all the logs are printed on the stand output, which is your current screen or the logs of your Docker container. Running on the AWS EC2 or bare metal. When you have implemented your application with Swoole PHP and like to run it on your production environment, you have decided how to manage the lifecycle of the Swoole application as a service. We have to think about the questions like how to better utilize the resources on the machine, how to manage of the lifecycle of the Swoole servers and automatically restart it when it fails, how to manage the log files of the Swoole application, how to reload the process when the code changes, etc. Adjust worker number of Swoole server. Swoole PHP has the support of automatically scaling up the process number and utilizing all the CPU cores on your AWS EC2 instance or bare metal machine. You don't have to make any server configuration change in your application explicitly. Swoole master process detects the Swoole number of the machine and launches the same number of worker process to serve the requests. You can explicitly define how many workers process will be launched by update the server settings. The default setting launching to many worker processes the same as CPU cores are optimized for the common cases. You should not change this except the following cases. You are running other services on the same machine as a database and like to reduce CPU usage by the application. If there is a large scheduling cost or there are blocking IO libraries within the application, you may have to raise the worker numbers to better utilize the CPU resources. It is recommended to adjust this number based on the A/B testing benchmark result. Demonize versus foreground. Having a demonized process means you can log out without losing the process. That is how much Linux service is running. When you run a foreground process, the process and all the processes created and managed by it are terminated when you enter Ctrl-C. Swoole application can be executed either in demonize and foreground mode. If you like to manage the Swoole server process within your PHP library or application, you can use demonize mode. If you like to manage the Swoole server process with another process manager, you have to use the foreground mode. When you use a process manager such as systemd or supervisor D, your Swoole application should be running with the foreground mode. Otherwise, The process manager will keep initializing a process for your Swoole application. By default, the Swoole process is running in the foreground mode. You can change this by updating the server settings. Team Night 1. Manage your Swoole application process. It is recommended to manage your Swoole applications with commonly used process managers such as Supervisor or Systemd. If you are running the Swoole application within an environment other than Docker, okay, you can update the log location, application directory, etc. based on the environment. The benefit of using Supervisor is the Swoole application is restarted when itself is crashed and for any reason. When Linux servers restarts, servers launch the Swoole application automatically. Manage the Swoole process with PHP code. You can also manage the lifecycle of a Swoole service with purely PHP code with your own process manager by turning the Swoole application into a daemon Linux process. By recording the process ID of the Swoole master process, you can send Linux signals by the process ID to reload code changes, stop or restart the application. Record the master PID into a file and the onStart callback functions when the Swoole server starts, and delete the PID file at the onShutdown callback function when the Swoole server is stopped. Manage the logging on Swoole application. Swoole prints logs on the console default. It's running foreground mode based on the log level you have set. Okay. Optionally, you can want to enable debug log and trace log on the Swoole server to see how things work internally. You have to compile Swoole extensions with options, enable debug log or enable trace log, and set a proper log level. You can make the decision on how to manage the logs, either managed by Swoole server itself or manage the logs by external systems such as Supervisor D. Because Swoole server is multiple coroutines applications, you can include the information such as process ID, coroutine ID in your logs with the time and concurrent state, variables when logging understand what is happening inside the Swoole server on an execution routine, or for an HTTP request, observing and caching with external proxy. All the Swoole server can be used as an HTTP server or HTTP2 server. It is recommended to put your server behind HTTP proxies such as Nginx or HTTP2 proxies such as Envoy. Then you can manage the cache, centralize and standardize the log files, integrate with your monitoring system to observe the health and performance of your Swoole application. Not to end. This is not the end, not even the beginning of the end, but the beginning of your Swoole and concurrency journey. By adopting the concept and Swoole into your company or team will largely increase the performance, reliability, scalability of your web systems. Compared with the other programming languages, we can improve the PHP system from two different directions: IO-heavy operations and CPU-heavy operations. As a release of PHP 8 GIT, we can expect a major improvement from the CPU operation side. Swoole is a major solution for optimizing the IO-heavy operations, so we can expect a major improvement of the PHP ecosystem by combining of power of Swoole async IO coroutines with PHP 8 GIT. We may see more and more use cases we have never seen before. This book has not tried to cover all the details of Swoole, and it cannot cover all the details because Swoole is actively being improved by the development team day by day. It only points the directions. If you are confused about how it works when you are building Swoole applications, it is just a start point. We may not have covered your questions in mind. If you have any other questions, please feel free to contact us. Thanks for reading. Tamam, kitabın sonuna geldik. Ya kitap bence genel olarak güzel anlatıyor konuları. Şöyle ki herhangi bir program dilindeki konsepti anlatmış, tamam mı? Şöyle notlara bakalım mesela. Yani Linux threadler, Linux soketler, HTTP2, RPC, gRPC, işte bazı runtime'ların karşılaştırılması, memory yönetimi falan. Ya bunlar Swole'dan ve PHP'den bağımsız. Bence bu konuları öğrenmek için bile bu kitap okunabilir. Ta ki ne zaman Swole'un detaylarına girdik. Kitap o zaman biraz saçmalamaya başladı. Çünkü her şeyi Swoole'la çözmeye çalışmış. Ama gerçek dünyada böyle bir şey yok. Bu gösterdiği örneklerin çoğunu kullanmayacağız gerçek dünyada. O yüzden bence oraya kadar okunabilir bu kitap. Yani dikkate alınabilir, ciddiye alınabilir. Ama en azından bu memory management, işte Linux prosesleri, threadleri, coroutines, işte soketler, bunları görmemiz ve bilgilerimizi tazelememiz iyi oldu bu kitap üzerinden. Bence her bir konu ayrıca bir kitap olabilir burada. Belki ileride onları tek tek de okuyabiliriz. Önümüzdeki süreçte ise okumak istediğim eBPF var. Bir de Go programı ile alakalı bir kitap var. Bakalım belki onlardan biriyle bir şeyler yapabiliriz. Ama bu video serisinin ve bu kitabın sonuna geldik. Umarım faydalı olmuştur ve yeni şeyler öğretmişizdir birbirimize. Ben hem yeni şeyler öğrendim hem bilgilerimi tazeledim. İyi oldu benim açımdan. Bir sonraki kitapta ve bir sonraki video serisinde görüşmek üzere. Eğer sorularınız olursa iletişime geçebilirsiniz benimle. Herkese mutlu ve sağlıklı günler dilerim. Bay bay.